you know, so what I'm going to do here is I'm going to snip these and just share the regular workspace that to work through these. I mean, there's a ton of resources to just get the answers you found out. I
I
mean,
know.
but
It's
if
just
you want
like,
to know how to do them,
I know
you have
the
to get some different information. So you should be seeing my screen now with problem one. Is it okay if I start here?
yes.
Okay. So these numbers on the outside, we're gonna deal with them in a bit. Taking an integral or an integrand is the undoing of a derivative. There's a power rule for so the integral of x squared. The uh, the integral of that you probably saw in class. You add one to it, and you divide by the new
Mhm.
exponent. So in this case, it's 2 plus 1 over 2 plus 1 plus, it's
Mhm.
really 6x to the 0. So that's 6x to the 0 plus 1 over 0 plus 1. That 6 just stays out in front. So that gives you x cubed over 3 plus 6x. And then you're evaluating that from minus 2 to 2. So what that means is you put 2 in first.
Mhm.
2
Okay.
cubed over 3 plus 6 times 2. And you subtract now, and you have to put negative 2 into this thing again here. So it's negative 2 cubed over 3 plus 6 times negative 2. And now it's just a matter of getting these numbers here. So it's 8 over 3 plus 12 minus, we'll leave that in parentheses, minus 8 thirds plus negative 12. When you distribute the negative, those all become positive. So you get 24 plus 16 over 3. And then 24 is really 72 over 3 plus 16 over 9. So you end up getting 88. I'm sorry, 88 over 3. Do you want me to enter the answers as we go?
Sure. That'd be great.
Okay.
Looking for my calculator, sorry. I found it. Okay.
Okay, we're up to the next one. So I'll be snipping that in. Okay, so same thing here. You just apply the power rule to each of these. You don't need to worry about the number in front. So for this one, the 3 becomes a 4, and you divide it by that same number. Minus 3, this 2 becomes a 3 over 3, plus 4. This x to the 1 becomes a 2 over 2, minus 3. And then there's x to the 0, 0 becomes x to the 1 over 1. And then you have to simplify. You don't have to simplify. It's probably good in this case. So it's 2x to the 4th
Mhm.
minus x cubed plus 2x squared minus 3x evaluated from 0 to 1. So you put the number 1 in for x, and then you subtract, putting 0 in. In this case, 0 and all of these is going to make it 0 because you're multiplying by 0.
Right.
So it's not
So
even worth putting in. 2 minus 1 plus 2 minus 3. So what do you got here? Is that 0? Huh. I get 0,
oh yeah, that is 0.
which I didn't expect, but it seems to be correct. Okay. So number 3. If you ever want me to explain anything, just let me know. There's
Okay.
no, I can't see what your
Uh-huh.
nonverbal body language here. So this is x to the power of 1. So this becomes x squared over 2 um, plus 3. Now this 1 over x, this is really 3 times 1 over x. This is a special case.
Mhm.
So the integral of 1 over x is the natural log absolute value of x. Um, it just is that without a much more explanation. So that's an exception you have to remember. And then you evaluate it from 2 to 3. So you always put that top number in first. So it's going to be 3 squared over 2 plus 3 natural log of 3 minus, and I always put this big parentheses here. So it's 2 squared over 2 plus 3 natural log of 2.
Mhm.
And WebAssign will literally accept any format you want to give it. You could actually throw all this in. We'll clean it up a little bit here, I guess. So this is 9 halves plus 3 natural log of 3 minus, this is 4 halves, so we'll call it minus 2 minus 3 natural log of 2.
And then
Um,
don't you put the 3 to the third? Like, would you do that?
this is a 2. You could, so you could go, I mean, this is where it's like, I don't know how picky your instructor is, but this is 4 over 2, so this becomes 5 halves. This is plus the natural log of 27 minus the natural log of 8, because it's 2 to the third. So you could write this as natural log 27 over 8.
Okay.
I mean, I wouldn't expect this, but that is what you could put in for the answer.
Okay.
I'm entering these again, so they're
Thank you.
you're getting, you can see that later. Some of the WebAssigns give you a practice problem or an example problem. I don't know if I see that here, but
Yeah, if you press like practice another, I think.
yeah,
Yeah.
they sometimes give you good enough examples that you can do these, but I understand, you want to have some. So I guess I've been glossing over a few things. You can bring like a 2 out, this 2 out. This is really 2 integral minus 2 to 0 e to the x dx. The integral dx, I'm sorry, the integral e to the x dx is itself.
Mhm.
It's the only one that is itself. It's a big deal. It's called the transcendental function. So for you though, like, what does that mean? Well, it's your choice. Like, maybe if I was learning this again, I would put the 2 on the outside. I'll do that for this problem. So it's 2, and then it's e to the x. It's the antiderivative. You have to evaluate that from minus 2 to 0. So this 2 stays on the outside. It's e to the 0 minus e to the minus 2. So e to the 0 is 1, 1 minus, and then e to the minus 2 can be written as 1 over e squared. So there's a lot of ways you can write this. You write this as 2 minus 2 over e squared. You could write it as 2 minus 2 e to the minus 2. All will be acceptable
Mhm.
in this
Did you
case.
multiply? Oh, you distributed it too.
You can distribute that in. You don't even have to though.
Right.
It's not like high school. It's not like it's whatever
Yeah.
they want you to do here. Or they accept a lot of forms.
Mhm.
So like the thing is, 1 and 2 were like really similar, and then like every one we've done since then has been different, and we're about to do 5 and it's different. 5 is, it's just something different altogether. So there's the integral of a number to the x equals that number to the x over the natural log of that number.
Okay.
So you have to know this. Like, there's no other way to do this problem if you didn't know it. So just this one is you have to memorize. This becomes 7 to the x over natural log of 7 evaluated from 0 to 1.
Okay.
So that's 7 to the x over natural log of 7 minus 7 to the 0 over natural log of 7. 7 to the 0 is 1. So we can write this as 7 to the x over natural log of 7 minus 1 over natural log of 7.
And can you put 1 in for the first one?
Yeah, I'm sorry. That was really silly. Yeah, it's supposed to be 7.
Okay.
And then these actually combine. So it's actually just 6 over natural log of 7. I'm curious, is the tutoring center doing it in person? Is it virtual? What are they doing?
Most of them, I go to the virtual one, but there's one location on campus where you can go and get in-person tutoring, but I just haven't really done that.
I understand. I just was wondering because I have no idea. I mean, everything's
Can you do
different now.
any in-person right now, or are you all on Zoom?
I mean, it's, well, like, I don't mind doing in person, but everybody's been okay with this. Are you
Yeah.
in Tucson?
No, I'm in
Okay.
Tempe.
Okay.
Yeah.
I mean, like for you, I mean, I would have no problem doing this.
Right.
It's just people are weird. Some people want
Right.
it, some people don't. know.
I believe my final is like over Zoom and not lockdown browser. So I'm like, maybe I can like meet with you.
Well, here's what they're doing. They want to see you on camera.
Yeah.
Which, I mean, it opens up a ton of possibilities to take pictures, take screenshots.
Yeah.
I don't know if they're going to have you share your screen. I think they just want to see you in front of your screen.
I feel like everyone finds. I've heard that people take their finals on Zoom. Last semester took them, and like the teacher knew, like everyone was kind of finding loopholes around it. So maybe
There's many ways to do it. It just depends if you're comfortable doing that. And I mean, there's some risk. So just up to you. 6 is a totally, completely different type of question. It involves this thing called a use substitution. And if you haven't seen this in class yet,
yeah, I've seen it.
yeah, okay. So there's all these like different types of use substitutions. Like sometimes it's exponents, or it's what's inside parentheses, or it's what's in the denominator. There's a bunch of these little things here. Here we're going to say that the exponent minus x squared is going to be our u, is our choice. You could do minus u, but I'm just going to, I'm sorry, just x squared, but I'm going to make that the whole thing. So you first take a derivative. So your derivative, and this is where it can be confusing because you're doing antiderivatives, and now you're taking a derivative. So that's just power rule derivative. And here, the next step here is to solve for dx.
Yeah.
So you'll write dx equals du over minus 2x. And then you go back to your integral and you substitute in for what you have to substitute in for. So you don't have anything for x, you don't have anything for 3.5, but you know that minus x squared is u, and you know that dx is du over minus 2x. If you have chosen correctly, the variable will be eliminated that you made the substitution for. Like here, this x cancels with this x, so it becomes minus 1/2 integral 3.5 u du. If you're comfortable with what I've done thus far, we can talk about the limits of integration. They change based on use substitutions. So your choice here is you can either change your limits of integration, which is what I think they usually teach, or you can integrate it, back substitute for u, and use your original limits of integration. Did any of that sound like something you've seen in class? Or okay, well, let me show you.
I've done use substitution, but
okay, so let's say you're doing u of 1. That means that x is 1. That's minus 1 squared, which equals -1. U of 0 is minus 0 squared, which is 0. So this number minus 1 takes the place of the 1. This 0 takes the place of that 0. So it's going to go from 0 to -1. This is like the previous problem where it's the integral of a number to a variable. So this becomes 3.5u over natural log 3.5. There's still a -1/2 in front, and you're evaluating it from 0 to -1. So this -1/2 is going to stay on the outside. You get 3.5u. I'm sorry, 3.5 to the -1 power over natural log 3.5 minus 3.5 to the power of 0 over natural log 3.5. And you get a mess here. So in this case, it's probably better just to enter the whole thing like as is. You don't have to simplify. If that's not clear, it's totally okay. It's
no, it's clear.
It's just a very
no, it's clear because we didn't really switch anything because you just kept the limits, right?
Yep. I'm just entering it now. So 1 over natural log 3.5. Okay. It says use a shortcut. Okay, so next question 7. Oh, we're doing good. If you want me to move to another section before finishing these, let me know. But
well, there's just 3 more, right? Is 9 problems?
yeah, we can get
just do
through.
these and then, I mean, I don't know how many, there's one more section. I don't know how many problems there are.
Okay, we'll see what we can do. If you were doing this problem for like a grade, other than a homework, you definitely want to sketch the graph of y equals 2x. You'd say, oh, it goes like that from 1 to 2, looks like that, and you'd realize you're finding that area right there. Well, now that you're in calculus, you know that to find that area, your limits go from a to b. That's what 1 to 2 is. Your function dx. So that function goes there. So then you find the antiderivative of this. It's x squared from 1 to 2. That's just power rule. There is sort of that intermediate step. It becomes 2x squared over 2, which reduces to that. And then it becomes 2 squared minus.
Oh. So when you say antiderivative, is that finding the integral?
Yes. Okay, so there's integral, integrand, antiderivative. These all mean the same thing. When you were studying derivatives, there was derivative, there was rate of change. There might have been one more. These all mean tangent.
Yeah.
These all mean the same thing.
Okay.
Okay, so this becomes 4 minus 1, which is 3. Pasting in number 8. Okay, kind of same thing here. It's the integral of your function, and your limits of integration go there. So the square root of x is really x to the 1/2. So sometimes this is where students get a little like, oh my gosh, it's fractions. I haven't done this in forever. Yeah, it's the same idea though. So it's x to the 1/2 plus 1 over 1/2 plus 1. This is 3/2. So it becomes x to the 3/2 over 3/2, and you flip the bottom. So it becomes 2/3 x to the 3/2 evaluated from 0 to 4. WebAssign will accept, 2/3 4 to the 3/2 power, but we'll just simplify it here since we're doing it in person. 4 to the 3/2. So 4 is really 2 squared. 2 squared to the 3/2. When you have an exponent and exponent, you can multiply them. So it becomes 2 cubed because the 2's cancel. 2 over 1 times 3/2. That's 8 times 2/3 becomes 16 over 3. All right, last question on this one. See example 5. Huh. Okay.
Yeah, I never really know what that means.
So the textbook that you probably got an ebook for or didn't purchase at all has an example 5 in it. So
I definitely got it, but I've never looked in.
All right, so this one again, they give you a function and they give you a to b. This one it's doable by hand, but we'll just end up using the calculator for the actual calculations. I'm going to write it slightly different. It's 1 over 1,000 times x squared dx from 40 to 100. Like the way it looks here, maybe it's unclear, but that's just a number in front, so it's still power rule. Here it's still power rule too. There's really an x to the 0 here. So this becomes 6x to the 1 over 1, which means you don't need to put anything down here, plus 1 over 1,000. This becomes x cubed over 3.
Where's the x from verse 6?
So there's really an x to the 0 here.
Oh.
So this becomes x to the 0 plus 1 over 0 plus 1. That's how it becomes that. And then you evaluate from 40 to 100. I'm going to use one of the many available online calculators to get this actual value because I don't know what it is. Integral 6 plus x squared over 1,000 from 40 to 100. Wolfram alpha will spit out that number. It ends up being 672. You would need a calculator
Yeah.
for that. Okay. Oops, I didn't submit that answer. Darn it. That's correct. Okay. So those are all correct. You got 100%. Some instructors give you extra credit for submitting them early. I guess this one doesn't. Like
I
if you
know,
do it
yeah.
more than a day early, they
Yeah, no, I don't think he does that. Yeah, okay. I don't know what the next section. I don't remember.
I pulled up
13,
13 or 14.1.
2 or 1. Yeah, yeah. That's it.
14.1. It's
So
due
whatever one
Friday.
is due Friday, yeah.
It is due Friday.
How many questions are there?
Let's see here. 8. They're longer though. You can do all of these in an online calculator in about 8 minutes, but I mean that doesn't help you for learning it. You literally just type these in and it gives you the answer.
I know it's funny. Like I did that last week because I just didn't have time,
Yep.
and I like took more time to like type it in than like I don't know. It was just funny.
Yeah,
Like,
yeah. It takes you more
that's like
time to. There's calculators for everything. So it really makes you question like why they're teaching you how to do this. But
also like why I don't know. I feel like the whole world is open book. Like why does it have to be locked down? Like in
it's
the
great.
real world, like you have access to everything.
That's right. It's a great way of thinking about the world because nobody cares when you're done with college. No one's going to ask you to do this question in an interview. They're going to ask
Right.
you how you can apply what you learned to help them in their company make
Uh-huh.
money or
Uh-huh.
do whatever they need you to do.
Right.
Okay, let's do. I mean, we'll do as many of these as we can. So integration by parts. There's different types of integration by parts. There is f of x times e to the x, or I'm sorry, let me do it this way. Let me not do it that way. It's a polynomial. So it's like a polynomial of x times e to the x, and it's usually x to the n times e to the x. And that's what this one is here. That's this type. So your u is always the p of x. So in this case, your u is going to be 9x. Your dv is always this e to the plus or minus x here, plus or minus. So this one it's the e to the plus or minus x. So in this problem, your dv is going to be e to the minus x dx. So you have to choose those, and if you choose wrong, you end up having to do the problem again because you get makes it worse than better. So on the left side here, you have to find the derivative. So it's 9 times dx. On the right side here, you're finding the antiderivative, minus e to the minus x. And so you got to be faster at this. I mean, it's this puts a negative down there. We'll talk about why that is, but and then you have to remember that integration by parts is uv minus the integral of v du. These are all things that you have. There's u, there's v, there's du. So you use these three pieces here. So u times v is minus 9x e to the minus x minus the integral of v du. So minus e to the minus x times 9 dx. And with a little bit of just, here's the negatives. These go together. Let's put that 9 in front. This becomes minus 9x e to the minus x plus the integral 9e to the minus x dx. And this one you can find the antiderivative of, or the integral of, the way you did in the previous section. So the antiderivative e to the minus x is itself, but because there's that negative has to come out in front. So that's negative 9x e to the minus x plus c. Was any of that clear?
I don't know. I think it's
Yeah.
we do it like another problem, like it will help.
Yeah. It's it is a pretty advanced topic. I don't think it should be taught. They end up. I just messed the submission up on that one.
There's a lot of problems that he shows us just because they're on the homework and not on the test. Like I'm sure there's going to be something like this on the test, but like some of the examples won't be.
There's it's like a bunch of different types of these that we're going to see, and they also have improper integrals, which is a topic that I don't know why they teach you guys, because it's not really relevant, but I'll try my best to explain this again. So this is actually a similar type to the one we just did. Your u is going to be the polynomial function. So in this case, it's 1 minus x. Your dv is e to the x. And this is always the case for these types of problems.
Okay.
Your du now, and this is again like because you've been doing so many antiderivatives, integrals, you're like you look at something like, oh my god, how do I do this? Well, it's just minus 1 dx. The derivative of 1 is 0. The derivative of minus x is minus 1 dx. Here, the antiderivative of e to the x is e to the x. You have to remember uv minus the integral of v du. So we have all of that. Your u is 1 minus x.
Mm-hmm.
Your v is e to the x minus the integral of v du. So these two together, well, I'll write out minus e to the x dx. These two negatives become a positive, so you get 1 minus x e to the x plus the integral e to the x dx. And this one is just e to the x. Sorry for interrupting you.
No, when you got rid of so you can ignore the line.
The line,
like the integral symbol, and
so these two negatives go together to make the positive.
Right.
That becomes positive. The integral of e to the x is e to the x.
Right, but I'm just saying, like you're allowed to like combine the signs, even though
yes, and that's very important to do. So this is considered complete here.
Okay. That makes a little more sense. Yeah.
They might show you there's a technique.
Shortcut.
There's kind of a shortcut with derivatives that I don't ever teach people, because you'd really need to understand what you're doing to be able to just apply that technique. But because usually by this time in the course, you're just like, let me get through it. I'm doing the best I can.
Yeah, and I'm hard because of like I refuse to like look at my grade because I don't know what it is, because I did so badly on the last exam that I'm like not motivated.
Well, hopefully this one, hopefully you get the grade you want, and then you're comfortable doing that again.
Right.
So this is another one of those where your u is the polynomial in front of the e. Your dv is the other thing, the integral of that. So the du here, the derivative on the left is 2x. On the right, this is a u substitution problem. So they can have those within these integration by parts problems. So I can write out the answer here, but I'm not sure how helpful that would be. Your u is usually this thing in the numerator here. So your u, which is not the same as this u, when that could become confusing. So ignore what's going on the left. It's 3x plus 4. Du is 3 dx. So when you solve for dx is 1/3 du. So your v is the integral now of e to the u. Instead of dx, it's 1/3 du. So your v over here is integral 1/3 e to the u du. Well, you know that is just e to the u, because the derivative of e to the u is itself. This 1/3 is just a constant. It can be out in front. But then you have to take this exponent, put it back in. So v is really 1/3 e to the 3x plus 4. you generally don't have time to do this, but if you could check your answer, like if you could take the derivative of this, you would get back to
Mm,
this original function here. So you have all the pieces you need. You need u, v minus the integral of v du. U is up here, v is here, du is here. So you have x squared plus 7 times 1/3 e to the 3x plus 4 minus the integral of v du. So we got 1/3 e to the 3x plus 4 times 2x dx. So I'll clean this left side up here a little bit. It's 1/3 x squared plus 7 e to the 3x plus 4 minus 2/3 x e to the 3x plus 4 integral dx. Unfortunately, this one on the right you cannot take the integral of because it's another integration by parts.
mhm,
So this is again kind of frustrating for students. You're like, wait, I just did it. Now you got to do it again. Yeah, you got to do it again. So this time your u is 2/3 x, and your dv is e to the 3x plus 4 dx. Okay. Du this time is 2/3 x. I'm sorry, 2/3 dx. Your v is exactly the same. So when you have to do multiple integration by parts, you end up reusing stuff that you had previously.
mhm,
So if you look up, it was 1/3 e to the 3x plus 4 for that. Now, there's a lot going on from this line up here, so I'm just going to start from that line. It's 1/3 x squared plus 7 e to the 3x plus 4 minus. So now we're gonna do the uv minus the integral v du, but that's all coming down here. So it's this u and this v. So that's 2/3 x, 1/3 e to the 3x plus 4 minus the integral of v du, 1/3 e to the 3x plus 4 times 2/3 dx. And that's all in parentheses here. So this is 1/3 x squared plus 7 e to the 3x plus 4 minus, and then I'll combine these. So it's 2/9 x e to the 3x plus 4 plus the integral, because you can distribute that negative in, 2/9 e to the 3x plus 4 dx. We've done the integral of this a number of times. It's the 1/3 e to the 3x plus 4 times the 2/9. You just bring that down, plus c, and then you have all this stuff that you bring down as well. So all this gets brought down, and it becomes plus 2/27 e to the 3x plus 4 plus c.
okay.
So let me give me a moment to enter this. It does take a while to get comfortable to do this. So
Yeah, I just wish they offered pass fail this year because of COVID and everything. It's just hard to learn online and everything with everything. And my class is really expensive.
I've had, so some of my international customers, they've asked me to write them emails to send their instructors to ask for this. Is nobody doing it, or is it?
No, I don't think anyone's any of ASU is doing it. Or any, I don't even think like U of A or NA is doing it either. And like last semester, like a lot of my classes didn't offer it. Like second semester freshman year, and like whereas like some people like were able to do it for like every class. Like some of my, I mean, I wouldn't have done it anyway last semester. I probably would have just done it for this class if I had the option, but you know.
I thought almost everyone got it for at the end, spring semester, but
Yeah, I don't know. So for some reason, most of my classes didn't offer it, but I didn't really need it anyways.
okay. This is your classic exam question. I have no idea if you'll get it on there, because it's you if you don't know the technique, the trick, if you will, like you just end up getting um, stuck on this. So the trick here, I hate even saying that, it's not even integration by parts. It's u equals x plus 7, and then you solve for x. So x equals u minus 7. Okay, and you might be like, why are you doing all this? I'll show you in a moment. Du is dx. Okay, so let's take this thing here, and we're just going to replace the stuff that we know about. Well, we know what x is. X is u minus 7. That's right there. We know that x plus 7 is u to the power of 6. We know that dx is du. Okay, and you might be thinking, well, how is this any better? Well, when you distribute this in, you get u to the 7th minus 7u to the 6th du. We've converted this original problem into a power rule problem.
Mm-hmm.
So this becomes u to the 8th over 8 minus 7u to the 7th over 7 plus c. And we know what u is. U is x plus 7. So we can substitute that back in x plus 7 to the 8th power over 8 minus these cancel. So you get x plus 7 to the 7th power plus c. No idea if you'll get that. It comes up all the time on a lot of standard tests. Oh, that's a 7. Okay. All right, up to number 5. Okay, evaluate the integral using integration by parts wherever possible. This one is different than the previous ones. This is a polynomial function of x times natural log of x. And in the past, we had set u equal to the polynomial. Well, here you don't do that. Here you set u equal to the natural log of x part, and you set dv equal to the polynomial of x part, which in this case is x to the 5th. And you wouldn't know to do that unless someone told you. So this is a very different problem than the ones we've done. If you don't do it this way, you're never able to integrate it. It's just I don't know. There's only so many ways to do these. So du is the derivative of natural log of x. That's 1 over x dx. V, this is power rule over here. You're adding 1, so it's x to the 6th over 6. And same thing, u v minus the integral of v du. U times v is natural log of x. I'm going to put the v in front, so it's 1/6 x to the 6th minus the integral 1/6 x to the 6th times du. So this times du is 1 over x dx. This x cancels with one of these. This becomes minus the integral 1 over 6 x to the 5th dx. And you can integrate that. Actually, that's absolute value of x. No, I guess not. So I read that. So this is just power rule again. So this is minus 1/6 x to the 6 over 6 plus c. So we're down to natural log of x minus 1 over 36 x to the 6th plus c.
Can you scroll up for a second?
Yes. How far?
Why is dv p to the x?
Well, I'm trying to tell you, like this problem, this is p to the x.
Okay.
It's like a case or a type.
Okay.
It's the polynomial. P of x means polynomial of x.
Okay, got it.
Because in the previous problem, you set u equal to p of x equal to the polynomial in front, but with the natural log, you do it this way.
Okay.
If you try to do it the other way, it gets worse, and you're like, this doesn't work. But so you have to know to do this type of problem this way, and the other type of problem the other way. Scroll. Okay, let me enter this answer. One over 36 x to the 6th plus c. I know you can't see them. I don't know that we're gonna be able to get through both of these. Do you have a choice? Let me copy them both in. You can decide.
Are there only 2 more or no?
What's that?
Are there only 2 more problems?
Yeah.
Okay.
I mean, we might be able to get through. I mean, I can give you the answers. I just can't do them
No,
both.
maybe just 2 1. Whichever one you think is probably more complicated.
So 7 is kind of that exam question where you need to know what to do. If you know to set u equal to x plus 1, and that means that du is dx, and then if you solve for x, you know that x equals u minus 1. You get the integral. Instead of x plus 1, it's u e to the u minus 1 du. You can actually change the limits of integration here based on your u. So u of 1 equals 1 plus 1. I'm just putting 1 in for x, so that's 2. U of 0 equals 0 plus 1, which is 1. So changes the limits of integration. Okay, now you're back to doing a integral by parts. So I'm doing this probably more complicated than I need to, but I wanted to emphasize that change of variable that we did in 5, because I think you're likely to see that on a test. So your integration here by parts, this is where it gets a little awkward because you want to use u, and there's already u in here. So don't forget, you can always change the variable to whatever you want. I'm just going to make it y e to the y minus 1 dy. That's totally okay.
Mm-hmm.
So your u is equal to y, and your dv is equal to e to the y minus 1 dy. So when you integrate, you get du equals dy. V equals e to the y minus 1. So your uv minus integral v du, your uv is y e to the y minus 1 minus the integral of e to the y minus 1 dy. And then you know that y e to the y minus 1 minus the integral of this just becomes itself. But we're not using y, we're using u.
Yeah.
So we just changed y to u just to make it easy on ourselves. E to the u minus 1 minus e to the u minus 1. But we have limits of integration to consider. I think we went from 1 to 2 was our change. So you have to put those numbers in now. So it's 2e to the 2 minus 1 minus e to the 2 minus 1 minus 1e to the 1 minus 1 minus e to the 1 minus 1 power. So this is 2e minus e minus e to the 0 is 1, and then that's minus 1 again, so that goes away. So it looks like it just becomes e on that.
Oh, okay.
Great. Actually, there is an 8, so we just won't be able to get through them.
Okay, no, that's fine.
Okay, this is a great place for us to stop. I'm going to send you a PDF of the notes and the screen recording tonight. It's within probably by 8:30. You'll see it.
Okay, great. And then so for Friday.
Yeah. So what do you want to do on Friday? Let me
So
actually.
that's what my